Hey guys, my name is Iman, and in this tutorial I'm going to show you the last example of how to work with TSAF. Specifically, I'm going to talk about batch field. So let's start with this example, energy. In this graph you can see monthly energy consumed in Australia over the last 36 years. The first thing that you can see, variance or mean to max is increasing, and that's the first sign of working with a non-stationary signal. In order to remove this undesired effect, one common approach in the literature is to apply log transform. So after you apply logarithmic transform, as you can see, mean to max or variance is almost constant. The other obvious thing that we can see here, that we have a linear trend. So in order to remove that linear trend, let's set D to 1. After removing trend, now you can see obvious spikes in the frequency domain. These spikes are corresponding to different harmonics. So let's choose 5 harmonics. And then the least common multiple between these harmonics is 12. So our seasonality is 12. Now let's remove seasonality. After we remove seasonality, if you look at autocorrelation, it's not, it's not obvious what kind of system we are working with, because we have a significant coefficient here, 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 here. And if you look at partial autocorrelation, the same thing. So it's kind of complicated, and we don't know what type of system is that. So in this case, you can use batch fit. By using batch fit, TSAF will create different models for you, and then at the end, it chooses the one with the smallest Bayesian information criteria, or BIC. Again, by using batch fit, you can set a different range for P. P is the order of our autoregressive part. For example, 1, 3, 6, 9, 12. And then you can set different range to D. But we know there is a linear trend here. So in order to save time, just set D to 1. And also you can set different range for Q. But again, to save time, just set it to 0. Now, TSAF is going to build me different models with different P, and then at the end, it's going to choose the one with the smallest BIC. So smallest BIC, or Bayesian information criteria, is achieved when P is 12, D is 1, and Q is 0. Do you want to save it? Yes. Now, we have the model, and we can forecast the future. How many samples do we want to forecast? For example, 24, how many times? 50 times, forecast. So again, the blue line is history, and these lines are corresponding to different paths for different forecasts. And you can save it. I think that's it. Just one more thing. If you want to work with these boxes, most of the time you just need this box and this box. But if you are working with a very advanced model, you can use these boxes too. Just if you are interested, please check ARIMA command in MATLAB. If you check this command, probably you will learn how to work with these boxes. Again, most of the time you don't need it. All you need is to work with these boxes. And one more thing, differentiation and removing seasonality are two simple filters. By using TSAF, you can apply an advanced filter to your signal. Again, if you know how to work with help filter, help filter, if you know how to work with this command in MATLAB, so we have denominator and numerator for the filter. So basically, you can define numerator and denominator for your filter, and then you can apply that filter to your signal. Again, most of the time you don't need it, but if you need it, the option is there. And I think that's it. Last but not least, if you're interested to know where I'm working, please check out this homepage. 2060 project probably is one of the best places to do research if you are working on renewable energy. Thanks for watching this tutorial, and I hope you have fun with TSAF. Thanks.